Hello wonderful person, this is Anton, and today we're going to discuss a somewhat bizarre mystery discovered in 2015 that still doesn't actually have a good explanation, but in some of the recent studies, scientists propose something that's truly mind-blowing. They basically explain all of this as exploding black holes. Okay, let's take a few steps back and let's talk about what event we're actually discussing and why right now at least several teams believe we might have actually witnessed the first ever primordial black hole basically exploding. Something that, if confirmed, would be very exciting and could potentially explain several mysteries all at once. But in a nutshell, we're discussing the most powerful neutrino ever found. The discovery from February of 2025 inside the European detector referred to as KM3 net. And this essentially involved a subatomic particle that crashed into our planet, but did so with so much energy that it basically made absolutely no sense. As a matter of fact, it was so much energy that it kind of threatens our current understanding of the universe. You can learn about the actual detection in one of the previous videos in the description, but let's just summarize everything super quickly, in case you don't want to watch that super amazing video from last year. So basically here we're talking about neutrinos, tiny particles that pass through us every single second, and that we often refer to as ghost particles. As a matter of fact, right now as I'm talking to you, trillions and trillions of them go through you and me without anyone feeling anything. And that's because they only interact with things through gravity or the weak nuclear force, not through strong force and not through electromagnetic interactions like most of the matter around us. Which means that detecting even one such particle is super challenging. And to do this, researchers built a few of these really complex and very large detectors, some of which are actually several kilometers across. And because these detectors are three-dimensional, it allows us to triangulate the location this particle is coming from and literally detect it in real time as it goes through water. And while one of the newest such detectors, KM3 net, only started operating very recently. This is actually located in the Mediterranean Sea, but on the bottom of the sea, in order to avoid any interference. And so in 2023, it detected a single muon, a heavy cousin of an electron, that in this case was extremely energetic. And following several months of investigations, researchers realized that this had to be caused by some kind of a neutrino. A neutrino carrying approximately 220 quadrillion electron volts of energy, which is 100 times more energy we've seen from any previous detection, and approximately 100,000 times more energy than we can actually produce in the labs right here on Earth using particle accelerators. And well, the big problem in this case was that we don't really know any standard astrophysical sources, not even supermassive black holes, that are powerful enough to produce this and to then send it across space in order to one day arrive to Earth. Or just to rephrase this, even the most powerful black hole we've ever seen is not able to produce something so energetic. And so in response to this mystery for the past few months, different teams were trying to figure out, okay, so if not a black hole, what can this be? And well, interestingly, so far, at least two separate teams seem to have come to the same unusual conclusion. They basically proposed that this is a black hole, but not the type we usually see, and not based on the event we usually expect. They actually suggest an exploding primordial black hole. Okay, so let's briefly talk about what that means. So unlike a typical black hole that's formed from the explosion of a star, or usually found in centers of galaxies, primordial black holes are theorized to have formed from the dense conditions just after the Big Bang, from basically primordial material. So essentially they existed for approximately 13.8 billion years, and were formed right at the start. As a matter of fact, many of them might have been the reason a lot of galaxies eventually started to coalesce, and might have been the reason why certain black holes are just extremely large. And while the most famous person to propose their existence was of course Stephen Hawking. He even predicted that if these black holes do exist, they might also explain the mysterious dark matter. Or just to summarize his main points, he basically suggested that if the universe was covered with these relatively small in size black holes that are actually kind of difficult to see, it might explain the effects we observe that we refer to as dark matter. But the problem is that detecting this would be super challenging. An average primordial black hole would be microscopic in size, and would have a mass of a typical asteroid or maybe a small planet. So basically we would have gravitational effects, but visually it would be impossible to see it. And theoretically they can even pass through an object without any interaction. You can learn about some of these concepts in previous videos in the description. But additionally, Stephen Hawking also proposed that black holes are not black after all. They actually do emit light through quantum effects. And specifically, he connected the concept from the quantum mechanics, referred to as the quantum foam, to the ideas behind Einsteinian principles and the event horizon of a black hole. And in essence, he explained that when the quantum foam interacts with black holes, occasionally it starts to produce real particles or real radiation. And so the black hole over time actually kind of starts to glow. But as a result of this glow, the black hole starts to lose mass, and for the lack of better words, starts to evaporate. And though for a massive black hole this evaporation is extremely slow, for a tiny black hole this evaporation seems to be much faster. And so the smaller the black hole, the hotter it gets, and the faster it starts to evaporate. And certain black holes of certain size might even start producing a light that becomes visible to us, and in theory can be detected. Now, they would still have to be pretty close to us to be seen, but that's sort of the main principle. Although eventually, all of these black holes are going to reach a threshold where it starts releasing so much energy that it basically results in a massive, powerful explosion. An explosion so energetic that it's going to produce some of the most energetic particles that can be produced anywhere. And so that's essentially where we're going with this. Because we now have at least 2 separate studies from 2 separate teams that seem to suggest a relatively similar phenomenon. In essence, they suggest that in order to produce such a powerful neutrino, we do require an exploding black hole that was approximately 10 million grams in mass, or approximately 10 tons, or 2 elephants, or the mass of your mama. But anyway, so what's really fascinating here is that we actually have 2 teams, but possibly also 2 separate explanations for how this black hole could exist, and more importantly, for how it could survive for 13.8 billion years. And that's because, theoretically, a black hole with a mass of 10 tons should not be possible and should not exist today. It should have exploded a long time ago. As a matter of fact, if you try to calculate the size of such a black hole, it seems to be much smaller than even fundamental particles such as proton and electron. As a matter of fact, it's something like 10 to the power of minus 14 nanometers in size. And this creates what's known as the lifetime paradox. A black hole that small should have been gone a long time ago and should have evaporated in just a fraction of a second. And so if this was created in the beginning of the universe, it should not have existed recently. But the point of these 2 studies was to try to present some kind of an explanation for how they managed to survive and for why this could still be a primordial black hole. And so the first team presents the memory burden hypothesis. This is a study by Andrea Bossia and Fabio Loco, whose names, as always, I most likely mispronounce, so my apologies. And so in this case, the team argues that as the black hole evaporates, the information inside of it might resist decaying. And this creates a kind of a back reaction that can slow down the evaporation process, potentially extending the life of this tiny black hole by billions of years. In other words, as the black hole in this case shrinks and starts to store information about what it ate, it might get cluttered, with the clutter creating a kind of a friction that then slows down its evaporation. So if you think of this as some kind of a leaky bucket of water, here this information basically blocked the leak, preventing the black hole from exploding. And if this hypothesis is correct, it also suggests there's a bunch of these black holes all over the place, and once in a while they might also explode, producing additional detections. Then the second team, and here we have Michael Baker, Joaquim Iguaz Juan, Aidan Simons, and Andrea Tham, once again, propose what's known as dark charge hypothesis, a different mechanism involving quasi-extremal primordial black holes that might carry some kind of a dark charge, or some kind of a hypothetical charge that prevents it from exploding, maybe involving some different particle such as a dark electron. And so here it's this charge that stabilizes the black hole for billions of years until it suddenly discharges and explodes billions of years later. And so basically we have these 2 exotic explanations for an even more exotic event. But the point is that both teams seem to agree that this might have been a primordial black hole, because this seems to represent the best fit for this impossible neutrino. And that's of course despite the fact that they seem to focus on different evidence. And so the first team focused on the quantum effects and how they potentially keep these objects alive for billions of years, and the second team suggests some kind of an unusual dark charge, or I guess dark electricity, that suppresses the emissions of energy, but allows much larger bursts, such as this neutrino, to occur. So in short, yeah, these are pretty complicated explanations, but they do suggest something really important. Right now, both of these studies point at the first official proof for the existence of the Hawking radiation, the existence of primordial black holes, and the idea behind exploding black holes actually being a real phenomenon. And additionally, this might also solve the mystery of dark matter, because if these black holes are real, they can definitely be dark matter that scientists have been looking for so long. And that's something that both teams note. If the universe is filled with these very small, long-lived black holes all over the place, they can definitely account for a lot of missing mass we seem to see in a lot of galaxies. And the good news is that we might not even have to wait that long to confirm this. Here, both studies suggest that if this theory is correct, we should be seeing even more of these events in just the next few years. And especially as KM3 expands and the new IceCube Generation 2, the detector in Antarctica, becomes operational. And so there's a very high chance we might see even more of these impossible neutrinos by the end of 2027. Which would very likely serve as the conclusive evidence for the existence of these bizarre objects, subatomic in size, with the mass of a couple of elephants. And so we'll definitely come back and discuss this more in some of the future videos, but until then, check out previous videos in the description. Thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM it directly, or by joining a general membership that grants you early access, and a few additional things. You can also buy the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.